Hello folks, so this is 2020 October November paper 1-2 and the question number is 15. It says it is about the chapter forces or pressure, we like to say, because it's concerned about floating of something else. So it says that a cylinder block of ice, excuse me, of a cross-sectional area 12 meters square. So its area is from here to here, it is a 12 meters square, is floating, partially immersed, submerged in the sea, partially submerged. The density of sea water is 1020 kg per meter cube. So density of water. A polar bear of mass of 400 kg steps onto the block of ice. Steps. The block of ice sinks a vertical distance d. So it sinks a little bit. What's the value of d? So initially the thing was floating. So that means the weight of the ice block should be equal to weight of the water displaced. Water displaced. So weight of ice block equal to weight of water displaced. Now what happens is when the polar bear steps onto it, the total weight will be increased. The polar bear causes increase in the weight. So, and it also will displace some more amount of water, and it is still floating. So that means that the weight of the beer should now be equal to the weight of extra water displaced by it. The weight of extra water displaced by it. And that weight of extra water will be equal to, so weight of extra water, let us say. So that's equal to mass of the beer into z is equal to, this weight of extra water will be equal to it is rho into rho of water, let us say rho of water into mass of extra water it displaces. So rho of water into mass of extra water, mass of extra displaced into z. So that's equal to z and z is cancelled. So this is a 400 is equal to, the mass of extra water will be equal to rho of water into volume of extra water displaced, and that's equal to rho w into, this is a into the extra depth that it sinks, so that's why here it is a weight of extra water displaced, it's equal to mass of extra water into z, that is equal to rho into volume of extra water, and that volume of extra water is equal to a into that extra depth here. So this gives us, this depth is equal to 400 by rho of water into a, that's equal to 400 by rho of water is 1020 into this, a is equal to simply 12 meters square. So when I calculate it, it becomes 400 divided bracket 1020 into 12 bracket equal to, it becomes 0.0326 something meters. So it becomes equal to 3.26 centimeter, and the answer closest to it is this is 3.3 centimeter. So choice B is the correct answer of this question.